Hello, welcome to a new video presented by DSC Charles ABB. Today we are going to study mathematics. And before we start studying mathematics, we're going to have a plan of mathematics. So we're going to come out with a plan of mathematics right now. We need to know that in mathematics, plan. Mathematics, according to me, mathematics is divided into three main parts. The first part in mathematics is going to be curves and curve sketching. The second part of mathematics is going to be vectors. And the last part of mathematics will be sequence, series, and probabilities. So, according to me, Yesterday Charles BB, I see that mathematics is divided into three main parts, and everything that we study in mathematics is in correlation with that. All these three. Now, before we start going into these three, we require a certain fundamental mathematics that we should have, and that is algebra. So, algebra, I don't usually classify it as being a general part of mathematics, because the main parts of mathematics are going to be the three mentioned above. But the fourth part is the one which is going to use in order for you to have the three bases up here. And mathematics are going to be applied in different subjects like physics, chemistry, even biology, and other science subjects which are applied. Now, algebra is the solving of numbers when we involve addition of one, addition of two, and addition of different with multiplications. All this is seen in algebra with different types of proof. In algebraic solution, you can be asked to prove why 1 is equals to 1 plus 1 equals to 2. But that one is already complex mathematics, and we are not going to treat that here. So we are going to have this is going to give us a general plan of mathematics. Now let's start with curves and curve sketching. Now, it's a broad part which constitutes of different parts of mathematics, which are going to be number one, the quadratic equation. We know that in mathematics, quadratic equation can be seen as being a chapter in different textbooks of mathematics. But I see that quadratic equation is only a part of curve sketching. The second part will be polynomials. The third part inside curves and curve sketching will be partial fractions. Or I can still classify partial fraction into algebra, because the partial fractions are not always involving equations nor curves, but they are involving how you can derive solutions for the curves that we have above here. I can classify partial fractions as curve and curve sketching, because it's mostly involved with equations and functions. Now again, here we are going to have study of functions. In the study of functions, you're going to have the mapping and relations. Here, we can also involve the logics. Here, you involve where x has a certain domain and y has also a certain domain in which it exists. The corresponding domain of x, y exists, and the domain of y, which exists with those two corresponding domains of x. Now, after having functions, still in curve sketching, we have differentiation. You'll see the reason just right now when I'm going to give you why I place differentiation inside curve sketching. And lastly, number 6 will be we have integration too. So these are the main parts of quadratic equations, of curve sketching. Curve sketching in mathematics, you're going to have quadratic equations, you're going to have polynomials, you're going to have partial fractions. You can also have logarithm and indices, number 7. Indices and logarithms. So generally, everything which has functions, generally, everything which involves functions, I am going to classify it as curve and curve sketching group. Now, the reason why I place differentiation and integration inside this part of curve sketching is that functions, we know that in order for us to draw a curve, we should have a certain table. That table is constituted of three main parts. The first part will be the x component, the domain of x which exists there. The second part will be the f prime of x, which is the gradient of the curve. And the last part will be y. So we need to know that anytime that we want to do a curve sketching, we should know first the differentiation. The differentiation is going to give us how the curve is moving. We need to know the domain of x so that we know where x exists. If I have a certain solution of x all over x minus 1, which is f of x, and I'm asked to plot this curve, I know that x will not equals be 1 because x all over 0 is not existing. So I'll exclude 0, 1 from being my value, and 1 will be the limit, because at that position, when I'm going to do the limit of x all over x minus 1 as x tends to infinity, is going to give me an infinite value, and I'm going now to try if it's a positive infinity or negative infinity, as we're going to see in curve sketching. So now, these are the main things which are being classified in curves and curve sketching. The second thing will be vectors. Number 2 will be vectors. Now, inside vectors, I've just placed the name vectors, but I just want to know that from definition of vectors, what are vectors? Vectors are any physical quantities which have both magnitude and direction. In addition to that, again, we can add the sense. But just saying that a vector has a magnitude and direction, we are quite alright, because when you have a direction, you must have a sense. Now, a direction, the magnitude is giving us the quantity of the physical quantity, or the magnitudes. How heavy is that physical quantity? If I ask you the question, I have a certain stone in front of me. If I pull the stone with a certain force, and I am a huge man, is that certain force is going to be the magnitude that I've placed on the stone. Now, the next thing again about the force, I need to know where am I pulling the stone. Is it necessary for us to know where the stone is being pulled? Yes, because force is a vector quantity. When I take this pen and I push it here, we see that the direction of this pen is toward my right. So we see that there is a force that I needed which has a certain magnitude, and the direction is toward the right. But now, direction toward the right is not a very precise name of direction. Anytime you're going to be asked to find the direction in mathematics, you're instead trying to find the angle with the horizontal. So coming back to a stone, if you have a certain force here, the angle that this is going to do with is horizontal is 0 degree. If that is going to have, the force will be the magnitude, and the angle with the horizontal will be, let's say, 30 degrees. So the direction in precise term is not toward east, not toward left. The toward is toward left, toward right, and toward northeast is mostly the sense. And the direction is the angle a vector does with a positive x-axis. In vectors, we have this number one, the vector proper. So we have seen now the vector proper. Now, there's another thing that I place in vectors that I wish everybody to do when to realize when they're solving mathematics. And the second thing I'm going to place in vectors will be complex numbers. Now, let's have a brief introduction to complex numbers. Complex numbers, actually, we have already known that from our basic mathematics in Form 1, Form 2, Form 3, Form 4, and Form 5, we know that anytime we have this equation, we always write at the end does not exist. But with advance in the next stage, which is lower seed and upper seed, we say that there's the existence of these complex numbers where x squared, I can send it to the other side and have negative 1. X, the square root of negative 1, will be plus or minus. Now the square root of negative 1 is being said to be an imaginary number which does not actually exist. And that imaginary number is said to be I. So this is ending by plus or minus I. Now, these are going to be placed on an Argand diagram, which has been created by a professor or in a French professor, Argand. Now, Argand still had analysis of vector for him to find the complex numbers in his sketch. Now, in the Argand diagram, we realize that you can have an x and a y axis. On the x-axis, we're going to have the real numbers of the complex numbers. We have the real part of the complex number, and here is going to be the imaginary part of the complex number. Now, let's say that we have a complex number z, which is equal to 1 plus I. I here, the magnitude of that I is 1. So in this case, I'm going to have 1 here in the imaginary zone, and I'm going to have 1 here in the real zone. Again here, the number that I'm going to have will be here. And according to Argand, this point here corresponds to a certain distance from the origin. He creates O here at the center. And now, when you have this distance with the direction, it is said to be vector. That's why I classify two complex numbers in vectors, because for us to characterize a complex number, we need both the magnitude here, so the z magnitude will be the square root of 1 squared plus 1 squared, which is equal to the square root of 2, and the direction will be this angle here, and this angle here you can find it with your tan theta. Tan theta is equal to, you have 1 here and you have 1 here. Tan theta is equal to opposite all over adjacent. The opposite of the angle here is 1, and the adjacent of the angle here is 1. So my tan theta will be equal to 1. So theta is equal to tan inverse of 1. So I find my answer. So that's why I classify a complex number as vectors, because you need the magnitude and the direction for you to have complex numbers. Now, again, the next part, the third main group that I initially said is combination. You have permutation, combination, sequence and series, or I can only see probability and statistics. Now, Probability and statistics is the third part, third main group that I've initially pronounced. Now, why do I classify and what is inside probability and statistics? Probability and statistics is one group apart because we need, in statistics, when we want to solve statistics, we need a sort of probability in it, and we need sequence and series to solve them. Now, for you to give the probability that a certain, you can have the existence of a certain event, you must need some form of combinations and permutation. In combination and permutation, it's just easy. If I have my four fingers, I can ask you to calculate the number of permutations, how this finger can be. I have this one, this two, this three, and this four. If you permutate them, how many permutations I'm going to have? The first permutation will be this one. This is the first permutation, all of them are four. The second permutation will be this one found here, this one here, but I replace this one into this side. And that's from the second permutation. All that I'm going to give you different permutations that you can have, but the combination that you're going to have with the four fingers here is only going to be one combination. Now, so all of them, I place them into probability because permutation, combination, sequence and series are mainly used to find the probability and the statistics which are involved in mathematics. And lastly, number four, which I didn't classify in the main basis of mathematics because this fourth one is used as the main basis to calculate the first three above, and this one is algebra. Where I said algebra is involved with the basic numbers 1 plus 1, 1 times 1, and all that. When you have to know negative 1 times negative 1, you have to have a certain number, and that one is going to be positive 1. All that is calculated in algebra. You have a certain form of complex algebraic solutions. Complex algebraic solution is going to explain to us why you have negative 1 times negative 1, which gives you positive 1. It's like it seems for me, but it has a sequence of events, a sequence of lines in order for us to prove this. Just imagine, we know that in multiplication is an addition of the number in repeated sets. Example, if I say 1 times 5 equals to question mark. In order for us to prove 1 times 5, I'm just going to say that multiplication is an addition of a set of the first number times the number of times that have been given. I know that. So it's going to be 1 added 5 times. So 1 plus 1 plus 1 plus 1, 5 times is going to give you 5. That's how you can find for algebra, for multiplication. Division, you divide by the number and have a certain, you have a certain quotient and you have a certain remainder where you have the value, the quotient and the remainder aside for you to have the value. Now, again, coming back to this solution, if I ask you the question 1 times negative 5, we already know from theorems of algebraic solution that the answer is going to be negative 5, but the question is why? And the answer, for us to have an answer here, we should go into complex algebra because here we cannot see how it's possible for you to have negative 1 which if I say negative 1 times 5, here you see if I say negative 1, I added 5 times, what do I have? Again, if I do negative 1 times 5, I see that the solution will be y. In order for us to solve the solution here, I just do negative 1 plus negative 1 plus negative 1 plus negative 1. All that 5 times is going to give me negative 5. Yeah, the answer is correct. But I will use complex algebraic solution for me to solve negative 1 times negative 5. This one is quite complex because I don't know how many times I have to multiply. So there we need complex algebra. And we're not going to involve it here. So, as a summary, we've seen that the plan of mathematics that you're going to have will be based on number one, curve and curve sketching, number two, vectors, number three, sequence and series, and number four, algebra. But the three main ones are going to be involved. Thanks for kind attention.